Hello guys, in this video we are going to see we have to find the force between an electron and a proton when they are 3.2 angstroms apart. Angstroms means it's a unit of measurement where it is equal to 10 power minus 10 meter. 1 angstrom is 10 power minus 10 meter. So when we have a proton and an electron nearby, there will be an attractive force, right? So they both move towards one another. So the second part of the sum asks us to find the acceleration of the electron as it moves towards the proton. The mass of the electron is given and the charge of the electron is also given. Incidentally, we know that the charge of the proton is same as that of the charge of the electron. So in this sum, we'll find two things. First is we have to find the force, and then we have to find the acceleration of the electron when it moves towards the proton. Now, next we have seen what they are given in the problems. The inputs they are given in the problem is they are given the charge of the electron, and that is 1.6 minus 1.6 into 10 power minus 19 coulomb. The charge of the proton is 1.6 and it is plus 1.6 into 10 power minus 19 coulomb. The mass of the electron is 9.1 into 10 power minus 31 kgs. The permittivity of free space is 8.854 into 10 power minus 12. Now, they need not always give the permittivity, but you have to remember this, okay? And 1 angstrom, as we already seen earlier, is 10 power minus 10 meter. The distance between the initial distance between the proton and the electron is 3.2 angstroms. So this is only the initial distance. As they move towards each other, the distance will become lesser and less. Now we'll see what the variables we have to find in this sum. First, we have to find the force between the electron and the proton when they are 3.2 angstroms apart. So that's the first one. The second thing is as the electron and the proton move towards one another, both are accelerated. But in this sum, we need to find only the acceleration of the electron. The acceleration of the proton is not asked in the sum. So these are the two variables that we have to find in this sum. Now we'll see a little bit theory required to solve the sum, only a little bit of it. We won't spend more time on it. Now, the first we are going to use the formula F is equal to 1 by 4 pi epsilon naught Qp Qe by R square. So Qp means charge of the proton and Qe means the charge of the electron. Now, this force was discovered by Coulomb, a French scientist. So he says that the force between two charges is directly proportionate to the magnitude, a product of the magnitude of the two charges. That is, the force is directly proportionate to Qp, the force is directly proportionate to Qe, and we can also say the force is directly proportionate to square of the distance between the center of the charges. This is very important. We always have to measure the distance from the center of the charges. Okay, so instead of this, you can also remember this formula like 1 by epsilon naught Qp Qe by 1 by 4 pi r square. That is, if you construct an imaginary sphere which joins the center of the two charges, then the force of attraction between the electron and the proton or any two charges is direct inversely proportionate to the surface area of the square created using between the centers distance between the centers of the two charges. If you want it, you can remember it this way, or else you can write it as the previous thing. Okay. So now force is the measurement since it is force. The unit of this force is Newton. Okay. So the next formula we need to find is F is equal to ma into E. This is Newton's second law, and we are using it. So as far as Coulomb's law is concerned, if the force is positive, it means that there is a force of repulsion. For example, when both the charges are plus or both the charges are negative, then we have a positive force. So it means like charges are present and hence it is repulsive. But if either of the charges is unlike charge, for example, one is positive and one is negative, since the signs are plus and minus, product of plus and minus is minus and the force will be negative. So you have to remember that if the force is negative, it means it's an attractive force. Next, we move on to the solution of the problem. So when we substitute f is equal to 1 by 4 pi epsilon naught qp qe by r square, when we substitute that, we substitute the values of qp, qe and r. Now, as far as epsilon naught is considered, we have a very useful result that 1 by 4 pi epsilon naught, when we substitute the value, we have the value of 1 by 4 pi epsilon naught as 9 into 10 power 9. Okay, this is a very useful result because you cannot remember the value of epsilon since it is in decimals, and it would be very difficult to use in problems. It's a very useful result is 1 by 4 pi epsilon naught is 9 into 10 power 9. Okay, then force is given by 9 into 10 power 9 qp qe by r square. When you substitute the value of qp and qe, we get 1.6 into 10 power minus 10 19 as the qp and minus 1.6 into 10 power minus 19 as qe. When you substitute r is equal to 3.2 into 10 power minus 10 whole square, we get the final answer as 2.25 into 10 power minus 9 newtons. Since it's a force, the unit is in newtons. So the final answer we get is 2.25 into 10 power minus 9 newtons. Now we would move to the second part of the problem. The second part is as the electron and proton approach one another, we have to find the acceleration of the electron. The acceleration of the proton is not required. So in this problem, so we have already found the force acting on the electron, which is equal to 2.25 into 10 power minus 9 newtons. We already know the mass of the electron, which is 9.1 into 10 power minus 31. So when we use the Newton's second law, F is equal to ma, we have 9.1 into 10 power minus 31 into a is equal to 2.25 into 10 power minus 9. We are substituting the value of f and m in this equation. So finally, when you bring the mass to the numerator, we have acceleration of the electron is equal to 2.25 into 10 power minus 9 divided by 9.1 into 10 power minus 31, which is equal to 0.247 into 10 power 22. So finally, the acceleration of the electron is 2.47 into 10 power 21 meter per second. Okay, so this is how we find the acceleration of the electron. The beautiful thing in this sum is we have not seen either the electron or the proton. It exists all around us, but we never see the actual electron and proton. But the power of physics is we are studying the acceleration of the electron of quantities which we don't even know, see or measure. Okay, so hope you have loved this video. And if you are preparing for exams, it is highly recommended that you do more test problems. So at the end of this video, there will be an attachment for more practice problems. I hope you do it and do well in your exams. That's it. Thank you. So if you have liked the video, I highly recommend you to subscribe so that you get more videos on this channel.